Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to another session on our trigonometry series. Today from Lesson 11.1 Trigonometric Identities, we are focusing on Pythagorean identities. So if you really want to understand Pythagorean identities very nicely and see how they are applicable to solve trigonometric identity questions, make sure you watch this video till the end. It's a must-watch video, and I would really appreciate if you would share it with all your friends of grade 11 advanced. So let's start this video. Pythagorean identities that we will be using for solving the questions. The first one involves sine square and cos square. Remember, they are added to give you 1. The second one is 1 plus tan square is equal to secant square. And the third one connects cot with cosecant. So 1 plus cot square equal to cosecant square. I would highly recommend you to learn these identities. How we get these identities and how we derive them is not in your curriculum, so I will not go into that much detail, but I want you to remember them so that we can apply them to solve questions. So let's see what kind of questions to expect in your exam from Pythagorean identities. So in today's session, we will be solving the following guided practice questions from your math book. So the three identities of Pythagorean will be useful for solving them. The 1A question, you need to find sine theta, and you are given the value of cos theta. So if you see all the three identities, then definitely the first one will help you because these are connecting sine with cos. So we are going to be using this first identity to get our solution. Also, before we go on further, I'd like to remind you that it is very important to look at the angle value or theta value, and if you see here, theta is given to be lying between 270 to 360, so that is the fourth quadrant. So we are going to use this information to decide on the sign, and we will be using after school to college or the cast diagram. I've already made a video on that which will help you for deciding on the positive negative sign convention for trigonometric ratio. If you did not watch it, I will provide the link in the description box. Make sure you watch it before you proceed to understand the sign convention in trigonometry correctly. Moving on, we'll be solving question 1b, where you need to find the value of secant theta, and you're already given the value of sine theta. So definitely for this one again, we are going to use Pythagorean, and to get to secant, we will use the fact that secant is the reciprocal of cos. So again, I think the first identity would be very helpful because from the first identity, using the value of sine already given as minus 2 by 7, putting it here, we'll be getting our cos, and taking its reciprocal, we will be getting our secant. So we will again use a little bit of reciprocal identity and the fact that secant theta is the reciprocal of cos theta. So this will really help us. And again, before we move on further to solve these questions, very important to look at the quadrant. So theta lies between 180 to 270. That means it is the third quadrant, and you have to be very careful upon the signs so that you don't do any mistake. So let's now solve the question one by one. These are going to be the final correct answer. How we arrived them, we'll look at in the next slide. Okay, so let's first write the Pythagorean identity. We need sine. So from the first identity, sine square theta plus cos square theta equal to 1. I will choose the one which I need to find. I need to find sine, so I will keep it here. This is the one that I need, so I will move cos square on the other side. When it is on the left side, it has positive sign, so when it moves on the right side, it will become negative. Okay, so this is the formula for sine square theta. Let's plug in 1 over 3, and there is whole square. Open it, so this will become 1 by 9. Now you need to take LCM, that means you need to make the denominator same. For that, let's take this to be 1, and I'm going to make this one denominator as the same as 9. So for that, I multiply with 9 up and down. So this thing comes out to be 9 times 9 minus 1, so 8 over 9. Now this is the value of sine square. Okay, but we need the value of sine theta. So definitely I will take square root. So sine theta will be plus minus square root of 8 by 9. Now 8 can be written as 2 square root 2, while 9 being a perfect square will come out of the radical sign, give you 3. Because 3 multiplied with 3 is 9. Now we will use this important information. The quadrant which is given here is fourth quadrant, and in fourth quadrant sine theta is negative. So I will only choose the negative value, so minus 2 square root 2 over 3. This is going to be your answer. Now if you want to remove the radical sign, you can also do one more step where you rationalize and then give the answer. Okay, let's solve another question. Again, we are going to use the Pythagorean identity, sine square plus cos square theta equal to 1. Sine theta is given, so I need cos theta. I'm going to move this on the other side. So cos square theta is 1 minus sine square theta. Plug in the value given and take the square. Now while you take square, be careful, there's a negative sign inside, but square will give you positive result. Square of 2 is 4, square of 7 is 49. 7 multiplied by 7, I hope you know. Again, we follow the same steps. We want denominator to be common, 49. So I multiply with 49 up and down. So 49 minus 4, 45 over 49. Now this was my value of cos square, but I need cos theta. So I'll take the square root of 45 over 49. Now when you do that, you will be getting both the signs, plus and minus. But we already have the quadrant with us. This is my third quadrant, and in my third quadrant, if we apply after school to college, so only tan and its reciprocal cot is positive. That means I will select for cos theta negative sign. So negative square root 45 over, now 49 is a perfect square 7. I can write it in this way. Let's find the square root of 45. So now if some of you will directly use calculator, you will make a mistake. Square root of 45 on calculator will come out to be a decimal, but remember, for trigonometry the final answer has to be fraction or radical. So I will do prime factorization. I'll start dividing with 3. So this is 1, 5, again 3 and 5. So that means these 3 are in pairs, so 45 can be written as 3 multiplied with 3 multiplied with 5. Or if I take square root of 45, it will be square root of 3 with 5. These 3 are in pairs, it will come out, so 3 square root 5. This is the correct value. So use this while you solve the question on square root. Okay, don't use your calculator because it will give you a fraction. Now we have got the value of cos theta, but what the question was asking you? It was asking you secant theta. So for final answer, you will do one more step where you finally take the reciprocal of cos. So when you take reciprocal of a fraction, means you flip numerator and denominator. So 7 in the denominator goes up and minus 3 root 5 comes down. So this is your final value. Now, some of you may think that the negative is down. It can also come in the middle or in the up. Both are okay. This is also correct. This is also correct. And even minus in the middle, not up, not down, not in numerator, not denominator. This is also correct. Any one answer you give will be correct, but make sure that you look at the quadrant. It is third. So the final answer for secant has to be negative. So with that, we have completed our video for today. We have seen Pythagorean identities. These are the correct answers. Now, some of you might be having one important doubt. So let me discuss that. For answer of 1b, from the previous slide, our answer was secant theta equal to minus 7 over 3 square root 5. Now you must be thinking this was the answer we got, but the answer here is different. Why? So the reason is because you don't like radical. This radical in the denominator is not considered nice. So to remove it, we will rationalize, means we will multiply numerator and denominator with the same radical, so that in the denominator, in next step, when you multiply 5 with 5, the radical is removed, and the final answer for this one would be minus 7 square root 5 over This 5 will come out, so 5 multiplied with 3 would be 50. So this is the final correct answer. Okay, so you will not leave your answer for secant theta in this form. You will rationalize. The process is called, I will write here for you so that you don't forget, rationalizing the denominator. I'm writing in short form DM, but it is the full thing, denominator. And this is very important to be done when you are solving a trigonometric question. Please remember, and don't use your calculator directly to give decimal answers. It will be wrong. That brings us to the end of today's session. Thank you for watching, and I hope you found this video useful. If you did, don't forget to like, share and subscribe to the channel. Also, let me know in the comment section if you want more videos for trigonometry, and please mention the exact topic that you want me to cover. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.